Hello and welcome to the Sleepy Physicist. I'm truly happy you're here. This is a place for you, whether you're relaxing in a dimly lit room, sinking comfortably into your pillow, or nestled on the couch, letting your thoughts drift effortlessly. Tonight, we're embarking on a journey into something truly remarkable: the concept of time. We won't just discuss what time is, but how it can subtly bend, expand, and flow differently right under your nose. The science of time dilation is more than just physics. It's a profound, almost poetic aspect of the universe's rules. It's about how waiting can feel different, how speed can influence reality, and how two people can experience the same moment at a different pace. A gentle heads up: this story might be so calming that you fall asleep before it's over. But if you're left with a mind that's a little too awake, remember that even wakefulness can be peaceful when it's filled with wonder. If you find this moment relaxing, a quiet like would be much appreciated. You might also want to subscribe for more content about science that inspires dreams. If you're comfortable sharing, I'd love to know where you're listening from and what time it is there. Your responses create a global picture of people settling down for the night, a beautiful map of rest. As always, this story is designed for relaxation and gentle learning, not as a substitute for professional medical or healthcare advice. It's simply a safe place to let your curiosity guide you to sleep. Now, let's begin. Tonight, your body feels at ease. Your breathing is slow, the room is quiet, and the clocks ticking on the wall seems to be in perfect harmony with your heartbeat. It all feels so predictable and constant. But what if I told you that clock isn't entirely truthful? It's not trying to deceive you, of course, it's just doing its job. The thing is, time isn't as simple as the steady rhythm it appears to be. Think of time more like a gentle river. Your body, your thoughts, and your memories are like small boats floating along it. Sometimes, without you even realizing it, your boat drifts faster or slower than someone else's. This is what we call time dilation. It may sound complicated, but let's try to feel it together. Imagine two birds flying alongside each other. One soars high where the pull of gravity is weaker. The other flies low where the Earth's gravity is strong. They flap their wings at the same rate, but when they meet again, they've experienced slightly different journeys. One has aged just a tiny bit less, with a few heartbeats spared, a small ripple in the calm current of time. You see, time can be stretched. It slows down when things are moving very fast, and it also slows down when they are close to something very massive. This isn't make-believe. It is Einstein's subtle and groundbreaking discovery. That time and space are intertwined in a single fabric called SpaceTime. And just like fabric, it can wrinkle and stretch. You've experienced time changing, haven't you? In moments of happiness, hours disappear like mist. But when you are truly waiting, for news, for healing, for a person, each second feels endless and heavy. This feeling isn't just in your head. It's a small reflection of what the universe does on a massive scale. Imagine floating in space, gently moving alongside the International Space Station. From Earth, it looks like you're moving very quickly. But if you were there, time would pass just a little slower for you than for someone on the ground. The difference is minute, just microseconds, but over time, it accumulates. Astronauts return home slightly younger than if they had stayed put. They don't notice the change. There's no dramatic whoosh or flash of light. It's just a subtle consequence of speed and gravity. A moment quietly folded within another. And that's the key: you don't feel time dilation. It doesn't cause a physical sensation. It's an imperceptible hum, like the lingering vibration of a deep cello note. So tonight, as you rest, you might wonder, is time moving at the same pace throughout this room? Is your head aging a tiny bit faster than your feet because of gravity? Surprisingly, the answer is yes. The difference is incredibly small, a mere fraction of a second over your entire life. But it is real. Just by lying here, you are evidence that time is flexible. Let your thoughts expand with this idea. Think of a tall, motionless mountain. A clock at its base ticks faster than a clock at its peak. Why? Because the mountain's height puts the clock at the top slightly farther from the Earth's center, and time, in a strange way, flows more freely there. This is a testament to how precise and wonderfully peculiar the universe is. You are not just an observer of time, you carry it with you. Every cell in your body has a rhythm. Your memories are woven into time's delicate fabric. As the cosmos spins and planets orbit and galaxies move away, you are moving with them. Your own personal timeline swaying among cosmic giants. This is why GPS satellites require special clocks. They orbit far from Earth, moving quickly with less gravitational pull. If their clocks were the same as ours, they would fall out of sync. So, They are continuously adjusted to account for the stretching and slowing of time. The world you navigate, the phone in your hand, and the maps you rely on all function because time is never exactly the same in two different places. So tonight, as you drift off to sleep, visualize time not as a rigid, ticking entity, but as a soft, flowing current. It is a river with gentle currents, whirlpools, and silent depths, and you are always floating on it. Perhaps this is why some dreams feel so long, or why a loved one's touch can seem to stop the world. Time is not just something we measure, it is also something we feel. And what we feel sometimes is that something is changing, that time doesn't always behave. But what happens when speed isn't just gentle but extreme? What happens when you move so fast that time starts to melt away? Close your eyes and imagine what it's like to travel at the speed of light. Out there, something extraordinary begins to happen. You are now drifting not just into sleep, but into motion. Picture yourself entering a sleek, silent spacecraft hovering just above the Earth's atmosphere. There is no noise, only the soft hum of the ship's systems and your own steady breathing, like waves on a quiet beach. With a soft burst of energy, the craft accelerates, moving faster and faster. You watch as the Earth shrinks beneath you, its blue color deepening, its clouds dissolving into gentle spirals. The stars once fixed now seem to stretch, and a subtle, strange phenomenon begins. Time slows down. Not for you, you feel no change. Your hands move normally. Your thoughts flow at their usual pace, and your breath maintains its slow rhythm. But if someone on Earth were observing you, they would see your moments lengthen. Your seconds would appear longer, and your movements would seem a bit more graceful, as if in slow motion. This is the slowness that comes with extreme speed. The closer you get to the speed of light, the more time bends to your motion. You aren't doing anything wrong, you're simply moving through space very fast, and the universe, in its generosity, allows you to borrow time to do it. This is not science fiction. It is the profound truth of relativity. It is not just a theory in the sense of being an educated guess, but a fundamental law because no experiment has ever disproven it. This is time dilation. When you move very fast, time genuinely slows down for you. It's not a trick of the mind, it's a real, measurable effect. Imagine two identical clocks. One remains on Earth, and the other travels with you at nearly the speed of light. When you are reunited, the traveling clock will have ticked fewer times. You will be younger.